to the CISA course series. I'm your instructor, and today we are diving into one of the most critical part of your CISA preparation, Domain 4, Information System Operations, Maintenance, and Support. So this domain carries the highest weight in the CISA exam, roughly 23%, and it represents the backbone of IT governance in action. If Domain 3 was about building systems, Domain 4 is about keeping them alive, reliable, and secure. You'll learn how to audit daily IT operations, handle incidents, manage change, and ensure how the organization recovers from operational challenges. Also, we'll deep dive into the incident management thing and how the escalations works, why this domain is important as a CISA standpoint, and also how we as an auditor will play a role in this domain. Okay, so moving on to our description, we'll start with introduction of IT operations. Okay, so let's begin. The operational backbone of information systems. So, information systems operations, as we all know, information system operations represent the phase where technology transforms from a design on paper to an actively functioning backbone of enterprise activities. While earlier domains emphasize governance and system development, Domain 4 focuses on the sustained performance and resiliency of systems that are already in production. This is where the audit function observes continuity, consistency, and compliance in daily IT activities. Operations ensure that data is processed accurately, services remain available, and security controls are continuously enforced. In today's IT environment, operational integrity determines business survival. Organizations rely on IT systems for logistics, communications, finance, and customer service. A single breakdown, whether due to failed patches, unauthorized changes, or data corruption, can have measurable financial and reputational impact. So, for auditors, Domain 4 is the practical space where governance and real time execution intersects. The auditor must assess not only whether processes are defined, but also whether they are performed consistently, monitored effectively, and improved continuously. So, as we already discussed, this domain holds approximately 23% of the CISA exam weight, making it most comprehensive in scope. It includes everything from routine IT operations, maintenance, and support to incident handling, backup recovery, and disaster preparedness. And so, in this, CISA exam focuses on our understanding of how operational control maintains system availability and data integrity, and how the auditor verifies evidence of control effectiveness through logs, reports, and performance indicators. So, moving on to our next slide, which is IT operations overview, objectives, and environment. Okay. So IT operations refer to the structured set of processes and activities that ensure day-to-day functionality of the information systems. This function typically operates within the IT service management framework, often aligned with ITIL, Information Technology Infrastructure Library, or COBIT principles to maintain a controlled environment. The primary objectives of IT operations include efficiency to maximize the utilization of resources. It may be hardware, software, or personal, while minimizing the cost and redundancies. Then, reliability to ensure consistent service delivery within minimal disruptions. Security to enforce confidentiality, integrity, and availability through operational discipline and continuity. To prepare system for rapid recovery and minimal downtime when failure occurs. Operations team typically includes system administrator, network engineers, database administrators, service desk teams, and change manager. Each role contributes to maintaining services quality and compliance with defined operational standards. So, from an audit perspective, the control environment in IT operations must include the documented standard operating procedures, abbreviated as SOPs, then access control mechanism aligned with the list privilege, segregation of duties between operations, development, and security, system monitoring and alerting tools integrated into management dashboard, and incident and change logs retained for traceability. So, in a mature IT organization, operational controls are embedded into automation, meaning that monitoring tool detects anomalies and trigger alerts before human intervention is even required. So, as an insight to an auditor reviewing operations should verify that monitoring reports are regularly reviewed, exceptions are logged, and accountability is assigned to responsible personnel. Evidence of operations control maturity includes up to date SOPs, consistent execution logs, and management sign offs on exception handling. Okay. Yeah. So, moving on to our next topic, job scheduling and data processing controls. Okay. At the heart of IT operation lies the data processing. It includes the execution of transactions, reports, and automated jobs that support business functions. Processing can occur in batch, online, or real time modes, depending on system architecture. Deep diving into batch processing. So, batch jobs process data in groups. For example, payroll calculation, invoice generation, or database reconciliation. Such processes are usually scheduled to run during non peak hours to reduce system load. As an auditor, they can focus on verifying that batch jobs are scheduled in correct sequence and depend on successful completion of prerequisite tasks. Also, control totals or run to run totals are calculated and compared to detect missing or duplicated transactions, as well as Exception reports are reviewed and signed off by operations personnel. Okay. So a failure in batch sequencing can result in incomplete or inaccurate outputs. A high risk event in financial system. Okay. Then diving into our next topic, which is online and real time processing. Online system allows immediate transaction input and processing. For example, ATM withdrawals, order entries, or online payments. Real time processing emphasizes instant validation, making input validation and processing accuracy critical control points. In such environment, typically as an auditor, we should examine input validation checks such as range limits, format controls, and authorization fields. Also, processing control mechanism that ensure calculation and business rules are consistently applied, as well as output controls, ensuring the generated report or data are complete and reach intended recipient securely. Yeah. Then monitoring and exception handling. Okay. An effective operational control system ensures every process, whether batch or online, generates exception logs and audit trail. Okay. So these are monitored using tools like Splunk, SolarWinds, or any SIEM dashboard, SIEM. Okay. Auditors validate that exceptions are categorized as minor, major, critical, and escalated according to impact level. Regular review meetings between operations and compliance teams serves as governance checkpoints. Auditors should select sample from batch processing logs, verify reconciliation totals, and trace exception handling outcomes. Okay. Weakness often appears when automated jobs fail silently, indicating missing alert configuration or poor monitoring design. So for CISA candidates, remember, processing control ensures data completeness, accuracy, and authorization. Three cornerstones of operational assurance. Okay. Moving on to our next topic, which is operational dependencies and role of automation. Okay. So in modern enterprise, operations depend heavily on automation platforms such as ServiceNow, Control-M, or Ansible to schedule, monitor, and manage workflows. Automation reduces human errors, but it also introduces systemic dependency on configuration accuracy. So, as an auditor, we must verify access to automation scripts is restricted and version controlled. Change records exist for updates to job parameters or triggers. Fallback procedures are documented in case of automation failure. Okay. The more automated the environment, the greater the need for configuration management and monitoring validation. Additionally, auditors assess whether performance metrics such as job success rate, average completion time, and number of failed jobs per month are tracked as key operational indicators. Consistent trend analysis demonstrate process maturity and identify systemic risk before they manifest as an incident. Okay. So understand automation's dual nature. It increases efficiency but amplifies risk if not being monitored. Expect exam questions that test comprehension of processing controls, scheduling dependencies, and exception reporting within automated environment. Okay. So moving on to our next topic, which is incident management life cycle. As life cycle, it will include detection, escalation, and resolution. Okay. So incident management is one of the most visible operational processes in any organization. It ensures that unplanned disruptions, whether hardware failures, software errors, or security events, are identified, recorded, analyzed, and resolved efficiently. Okay. An effective incident management process follows the ITIL defined life cycle, which consists of detection and logging. Every incident must be recorded in a centralized system such as ServiceNow, Jira, or Remedy. Lot of organization also uses RSA Archer for such detection and logging purposes. Then categorization and prioritization. Incidents are assigned categories: hardware, software, network, security, and prioritized based on the business impact and urgency. Then investigation and diagnosis. Technical teams isolate root causes and propose temporary or permanent fixes. After investigation and diagnosis, we move to the resolution and recovery part where services are restored to normal operational levels. Post that, closure and review happens. The incident is documented, closed formally, and lessons learned are recorded. So, from an auditor's standpoint, three factors define the maturity of incident management. Okay. First is timeliness, measured by mean time to detect and mean time to resolve. Okay. Consistency, all incidents follow a uniform escalation path. And documentation, every incident log include timestamp, personnel involved, and corrective action. Incident management logs provide auditors with evidence of operational discipline. If recurring incidents are not formally categorized as problem, it signals poor root cause analysis, and it's a red flag in an audit. Okay. So we as an auditor must verify that incidents are logged immediately upon detection, categorized properly, and closed with management review. Metrics like MTTR and SLA compliance are reliable indicators of the effectiveness of operational response mechanism. Okay. Then jumping to our next topic, which is problem management, root cause analysis, and prevention. Okay. So while incident management restores services quickly, problem management ensures the same incident does not reoccur. Okay. So it focuses on root cause identification, long-term remediation, and preventive actions. So the key steps would include correlation of repeated incidents to identify systemic failures, root cause analysis using methods like 5 whys, Ishikawa or fishbone diagram, or fault tree analysis. Okay. Documentation of workaround procedures until permanent fixes are implemented, and integration of solution into change management process to prevent recurrence. So from an audit perspective, the auditor must assess whether the problem management processes link each problem record to one or more related incidents, documents the RCA clearly with the evidence of technical validation, tracks corrective actions and their effectiveness post implementation. A common operational weakness is incomplete linkage between incidents and problems, leading to short term fixes without structural improvement. So, the people who are appearing for the CISA exam, you guys can expect questions distinguishing incident and problem management. Remember, incident is equals to restore service, problem is equal to prevent recurrence. Auditors verify the existence of problem records, RCA documentation, and management approval of long-term remediation. Moving on to our next topic, which is change management lifecycle, usually consists of authorization, testing, and control. So, change management is among the most critical control in IT operations. It ensures that all modification to systems, configurations, or code are reviewed, approved, tested, and documented before being implemented in the production environments. Okay. So typical change management workflow follows a request for change raised by user, developers, or system administrator, then impact assessment, which evaluates potential risk, dependencies, and downtimes. Then comes the approval process, which is change advisory board, authorizes high risk changes. Then testing in staging environments, which verifies that the change performs are approved and as intended. Okay. Then implementation in production, conducted during control maintenance windows. After implementation in production is post implementation review, which confirms successes and assesses the residual risk. Unauthorized or emergency changes are one of the most frequent audit findings. Such changes bypass governance mechanisms, increasing the probability of outages or security incidents. So, as an auditor, we assess whether the organization maintains a change register tracking all requests, approval, and implementation. Each change request includes documented impact analysis and rollback procedures. Emergency changes are logged and retrospectively reviewed. Segregation exists between those who request, approve, and implement changes. Okay, so auditors should sample change record, validate approvals, and confirm rollback testing evidence. A strong change management process minimize unplanned downtime and prevent configuration drift. Weakness in this area often correlates directly with increased incident frequencies. Okay. Moving on to our next topic, which is configuration management, baseline integrity, and CMDB control. Okay. So configuration management complements change management by maintaining the integrity of the IT environment. It establishes a configuration baseline, the approved state of all system components, and tracks any deviation over time. The configuration management database CMDB act as the authoritative source of asset and configuration information. It records hardware specifications, software versions, dependencies, and relationships between systems. So, from an audit standpoint, the configuration management ensures all production components are registered and mapped correctly in the CMDB. Configuration changes are authorized and documented through the change management process. Periodic configuration audits are performed to detect unauthorized modifications. As an auditor, will review CMDB completeness and accuracy report, logs showing synchronization between discovery tools and manual updates, alerts or reports highlighting unapproved changes. Configuration drift is the gradual divergence between intended and actual configuration and is one of the most significant operational risks in modern hybrid infrastructure. So, as CISA exam standpoint, candidates must understand that configuration management ensures system integrity. Expect exam questions testing the relationship between configuration control, change management, and incident prevention. Moving to our next topic, which is backup strategy and testing, ensuring data continuity. So, backup and recovery controls provide assurance that data can be restored in the event of corruption, deletion, or disaster. Auditors evaluate both design and operational execution of backup processes. So, key control objectives include the frequency, backup performed according to defined schedule, daily, weekly, or incremental, scope, identification of systems and data critical to business operations, security, encryption of backup data during storage and transmission, retention, compliance with legal and organizational data retention policies, and testing, periodic restoration tests to verify usability of backups. A backup that is never tested may provide a false sense of assurance. Many organizations have discovered during incident that backups were incomplete, corrupted, or encrypted by ransomware. So in this case, auditors examine backup logs and error reports, results of restore tests, including validation of recovery service success, documentation specifying backup ownership and storage locations, on-site, off-site, or cloud. So insight as an audit, the most common audit deficiency is the absence of evidence proving that backup can be successfully restored. For CISA candidates, focus on RPO, recovery point objectives, and RTO, recovery time objectives. They define acceptable limits for data loss and downtime respectively. Okay. Moving on to our next topic, which is disaster recovery planning and business continuity. Okay. So, disaster recovery and business continuity processes form the final layer of defense within the operational controls. They ensure that critical business functions can continue and systems can be restored within acceptable time and data loss limits following the major disruptions. Disaster recovery planning focuses on IT systems, restoring infrastructures, applications, and data. Business continuity planning extends beyond IT, maintaining overall business operations, including people, facilities, and third party dependencies. An auditor examines whether the organization has a formally approved DRP and BCP policies reviewed by executive management, clear identification of critical systems and prioritization for recovery, defined recovery time objectives and recovery point objectives, metrics for each system, redundant site strategies, hot, warm, or cold sites, with associated cost and readiness trade offs, evidence of periodic testing of DRP and BCP through simulations, failover exercises, or tabletop reviews. Each DRP or BCP test must produce documentation showing test scope and objectives, participants and roles, issues identified and corrective actions, management approval of closure. Without regular testing, the existence of a DRP document provides no actual assurance. A functional audit focuses on execution maturity rather than documentation alone. Okay, so the auditor must confirm that DR and BC plans are aligned with business impact analysis results. ISACA expects candidate to differentiate between DRP, which is a technical restoration, and BCP, which is organizational continuity. So expect scenario-based questions linking DRP objectives with operational downtime metrics. Then moving on to our next topic, which is maintenance and patch management, sustaining system integrity. So, maintenance and patch management are preventive operational controls that safeguard systems against degradation and known vulnerabilities. They ensure systems are not only functional but also secure and compliant with emerging risk landscape. So, key control elements includes the patch identification. IT team continuously track vendor advisories, CVE, databases, and security bulletins. Then patch evaluation. Patches are assessed for criticality, compatibility, and potential operational impact. Then testing phase, where patches are tested in staging environment before production rollout. Then deployment of the patch. So approved patches are deployed during maintenance window, minimizing business disruptions. And at the last, the verification, which is post installation validation, ensures system stability. So auditors in this case reviews the patch management policies and schedules, vulnerability reports correlating to unpatched system, documentation of approval workflow and testing results, evidence that critical patches are applied within vendor recommended timelines. Failure to patch promptly is one of the leading cause of security breach. A well-structured patch management process demonstrates both security diligence and operational maturity. Understand how patch management links directly to risk mitigation and configuration control. Candidates may encounter exam items emphasizing change approval, rollback procedures, or emergency patch exceptions. Moving on to our next topic, which is performance and capacity management, which basically outlines measuring operational health. So, operational performance monitoring provides visibility into system health and identifies capacity constraints before they affect service delivery. Key performance areas include system performance metrics, CPU utilizations, memory consumption, disk I/O, and response time. Then network performance focuses on bandwidth usage, loss of packets, and latency of the network. Then database health, which emphasizes query efficiencies and the transaction rates. There may be a certain situations where the SQL query have not been optimized, which will which will increase the CPU utilization, as well as the database memory will be locked, or it will reach to the maximum state where the application may uh, experience a bit of latency, or there may be a case that application isn't able to perform the intended operations. So database health is actually a very major aspect query efficiencies, and the transaction rates. We need to keep them in monitor state, because this will also affect the memory utilization, CPU utilization, and response times for an application or operation may face a bit delay in their operations. Then also we should conclude the capacity planning. So forecasting demand growth based on historical usage patterns. Auditors verify that organization use monitoring tools such as, for an example, Nagios, Zabbix, or SolarWinds to collect and analyze these metrics. So these monitoring tools can be any other tool. Just for an example, we had taken this, but it is not just limited to this particular tools. Okay. Regular performance reports should be reviewed by IT management and correlated to incident and change records. So for capacity management, auditor assesses whether growth projections are documented and aligned with the business plans. System upgrades or resource allocations are triggered proactively based on capacity thresholds. Performance degradations are analyzed for root cause and trend recurrence. Organizations with mature operation use dashboard that automatically highlight anomalies and SLA breaches. Auditors should confirm the accuracy of these dashboards and verify periodic management review. As an insight to an audit, performance management evidence demonstrate preventive governance. For CISA candidates, expect exam questions that test understanding of capacity planning, SLA monitoring, and proactive risk indicator within operational oversight. Then moving on to our next topic, which is audit evidence collection, documentations, and common findings. Auditing operational environments relies heavily on tangible evidence. Documentation, logs, and system outputs represent the most reliable form of proof for operational control design and effectiveness. Common type of operational evidence includes system logs, job execution records, access logs, and change tickets are the example of system logs. Then reports to make reports for backup verification, incident response metrics, and SLA performance dashboards. Then change control records, requesting forms, approvals, and rollback confirmations, and also configuration report. So CMDB extracts showing asset inventory and versioning. So when evaluating evidence, the auditor should focus on authenticity, completeness, and traceability of that evidence or the operation. Okay. So for instance, a backup log is only valid if it correlates to system timestamps and error-free completion records. Electronic evidence should be retained according to data governance policies and protected from unauthorized alterations. So common audit findings in domain 4 includes unauthorized emergency changes lacking retrospective approval, incomplete backup verification logs or untested restore processes, inconsistent incident closure documentation, configuration drift between production and baseline inventories, lack of trend analysis on performance and capacity metrics. Each finding should be linked to business risks such as downtime, financial impact, or data loss. Expect scenario questions requiring identification of missing evidence or ineffective control validation. ISACA emphasizes on auditors' ability to connect control weakness to potential operations or continuity risks. Okay. So, domain 4 bridges the gap between the governance and execution. It demonstrates how operational consistency transforms strategic IT plans into measurable reliability. A well-controlled operations environment reduces incident frequencies, improve compliance posture, and build business trust. Okay. In order to summarize, operation maintains service reliability and enforce daily controls. Maintenance preserve system integrity and compliances. Support ensures rapid response to incidents and proactive improvement. Continuity planning guarantees survival during crisis. Auditing validates evidence of all these processes. Okay. So the auditor's goal is not just to verify the existence of operational controls, but also to evaluate their effectiveness, traceability, and alignment with the business continuity objectives. So these are some of the takeaways. So understand operational control categories: preventive, detective, and corrective. Be able to differentiate between incident, problem, and change workflow. Link evidence types to assurance objective. Prioritize audit findings by risk and business impact. So, operation is not just the backbone of IT, it is the living system that keeps every control, every policy, and every business decision functioning. And auditor's insight here defines the true measure of resilience. So that's it for domain 4. Stay connected for domain 5. We'll soon release the video on domain 5 as well. Thank you.